what you're going to see over the next couple days are some diagrams that are going to involve us setting up proportions. So if you're still having trouble with the solving of proportions, well, we're going to do a lot of practice with it over these next few days. So you're going to see a bunch of these kind of problems happening that you're going to be able to work with. And all of these are true in some way because of similarity. For example, this first one is true because of angle-angle similarity. The parallel lines happening here are going to create angle-angle similarity. So if a line is parallel to one side of a triangle intersecting the other two sides, then it divides the two sides proportionally. So this is also called the side splitter theorem. It's called that because it splits off the sides. So the way that I usually write this one is that we have piece over piece of the red side is equal to piece over piece of the blue side. So that's the way I'm usually going to write these and set up these equations. So then from here, we also have the converse. And the converse is going to involve saying that this is a test for parallel as well. So if I know that the piece over piece is working, then that tells me that we can know that those sides are going to be parallel to each other. So that's the next part. If the piece over piece is true, then the line is parallel. Which in this case would be T to U and Q to S. These would be parallel. If that piece over piece ratio reduces the way that it's supposed to. All right, so we're gonna have 3 of these different proportion problems, different type of proportion problems. For now, we're just going to focus on this one, the piece over piece equaling piece over piece. But just like with our other proportions, the key is going to be to keep consistent. So we're going to have piece over piece of the red is going to be equal to piece over piece of the blue. That's what we're going to set up. And the distance that we don't know is this distance right here. So first off, we're going to set up piece over piece on the red. So I'm going to set up 9 over x. 9 and x are my pieces on the red, equals my piece over piece on the blue. So I want to make sure, remember the rule is to keep consistent. So since I put the 9 on top on the red, what do I want to put on top on the blue? Well, it's going to be 6 because that's the one that's kind of furthest away from my points here, from my starting point. So since 9 goes on top on one side, 6 goes on top on the other side, and on bottom is going to go 4. And now we're going to solve these the same way we've been solving these, which is I want to get rid of my fractions. So I get rid of my fractions by multiplying by whatever's on the bottom. I have x on the left side. And on the right side, what's on the bottom? 4. So I'm going to multiply by 4 to get rid of my dividing. On the left side, ready for the fractions to go away. X's cancel, no more fraction. Negative 36 equals 4's cancel, no more fractions. And we have 6 times x. And now, that should be straightforward enough to solve. Because we have 6 times x equals 36. Well, that's multiplying, so we're going to undo it by dividing. So we're going to divide by 6, and we're going to get x equals 6. And we're being asked for r to q. Is the answer for x we just found that length of r to q? R out to q here. Oh, yes, it is. So r to q is just 6. If I were asked for r out to u, that entire side, what would that be? What would that entire distance from r to u out to be if I were asked for it? It would be 15, because I would take my 6 that I just found and add it with the 9 to get my entire side. So do pay attention to what side length and part you're being asked for there. Questions on that problem before we move on to the next one? All right, a couple more. All right, we're finding the length of y to z. Again, we're going to have piece over piece in the red equals piece over piece in the blue. So this is the part we don't know. So piece over piece in the red, I'm going to do x over, I'm going to start with x on top. And I will give you about a minute. See if you can set up and match up everything else correctly in the setup of the equation. My other red piece is a 36. Since I put x on top, what do I put on top on the other side? It's going to be the 35. Going to go on top. Keep consistent. And then that means on the bottom it's going to go 44, since I put the 36 on the bottom. Multiply to get rid of your fractions. So over on the left side, I have a 36 on the bottom, so I'm going to multiply by that on both sides to get rid of my fraction. Over on the right side, I have a 44 on the bottom, so I'm going to multiply by 44 on both sides to get rid of my fraction. 36 is canceled. No more fractions. So we have 44x. Over here, 44 is canceled. No more fractions. And we have 35 times 36, which is going to be, I believe, 1,260. So again, pretty straightforward to solve from here because we're just going to divide to get rid of the multiplying. So dividing by 44 on both sides. And to the nearest tenth, it should be 28.6. And it asks for the distance from y to z. So y to z is indeed the distance that we solved for. going to put approximately because that's rounded. Questions there?
So would it matter if you did like 44 under the X? Like I know you said keep it.
So you wanted to match the 44 with what?
Like you have to put it in like that exact way, or did you get it the same?
There are other orders. So question being, you have to put it in this exact order. No, there are other orders that you can go in. So for example, I could choose to go 36 over X. But if I do 36 over X, since I put 36 on top, now I want to put the 44 on top. Keep it consistent. And that would still get the same answer. You should wind up at this step regardless of that setup, as long as you're keeping consistent in the order that you set things up. If at any point you match up 44 with X, now you're not keeping consistent. And now you're going to get a different answer. But as long as you keep consistent and match up your red pieces and blue pieces with each other, match up your 44 with your 36, match up your 35 with your X. That's what should be happening in your proportion. You should basically be able to explain to me your system of how did you know what to put on the left side? How did you know what to put on the right side? How did you know what to put on top? How did you know what to put on bottom? In this case, I put all my red pieces on the left side and all my blue pieces on the right side. And I put all of my closest pieces to X. I put those on the bottom. I put the farthest away pieces from X. I took and put those on the top. That was my system for what things I put where. Keep it consistent. That's the important part in setting these up. All right, moving on. So remember I said there was a converse to test if things were parallel. That's what you're going to see here. So what we're going to do here is we're going to check piece over piece on each side and double check that we're getting the same thing. Because if they're parallel, what should happen is that these should reduce to the same thing. So my piece over piece on the left side, I'm going to put 90 here over 50. Well, those are both divisible by 10, so we're going to have 9 over 5. So 9 over 5 is now my target, and that's what I want the other piece over piece to reduce to. That's what I want my other piece over piece to reduce to. So we have, if we put 90 on top for the red side, over on the blue side, what should we put on top? It's going to be the 72. Keep it consistent. And since we put 50 on the top, on the bottom, on the red piece, we're going to put 40 on the bottom on the blue piece. And those are both divisible by 8. 72 divided by 8 is 9. And 40 divided by 8 is 5. Oh, wow. They were the same thing. That's what we wanted to happen. So that's our goal. We throw our hands up in celebration and say, it works. We did it. That means that P to S is indeed parallel to Q to R. Because the sides are split in the way that they're supposed to be split. So next time we'll look at 2 more of these type of diagrams and theorems that are going to involve setting up proportions and solving these kinds of equations that are tied into our similarity.